Hi friends, in today's video we're going to learn about Lorenz's contraction. In the previous videos we learned about time dilation and also about relativistic mass. All these two factors can be true when we travel at the speed of light. Like that, Lorenz's contraction can be seen in our naked eye when we travel at the speed of light. So let's learn about Lorenz's contraction. We can say this is Lorenz's contraction or length contraction. With the name, we can infer what this might be. Length contraction. That means the length is getting smaller. So for Lorenz's contraction, let me give an example. So first, let's say I've drawn a train. Let's say this is a train. I'm not good at drawing. Let's say this is a train. No tires. So here, let's say this train is moving. This train is at motion, and also you're inside the train, standing here, inside somewhere, inside the train. So how would you measure the train? With a ruler or perhaps with a tape? So let's say, now you'll keep the tape here and then keep it here and then take the measurement. So let's just keep a random numbers. For example, 210 meters, like that. Let's say that the length of the train in your perspective is 210 meters in your perspective. So let's say now I'm outside. Your perspective is 210 meters. Now let's say I'm outside watching a train. What would be the measurement of me? How would I see, or what will be the length of the train in my perspective? Well, I can't take a tape and measure it because the train will move on before I keep the tape. So what I can do is that, let's say that I'm standing here. I can have any stopwatch. When the first part of the train passes me, I can start my stopwatch. And finally, when the last part of the train passes me, then I can stop the stopwatch. So and we also need to know, let's say that I also know the velocity of the train. Let's say the velocity of the train is 3 meters per second. Not speed, not velocity, because velocity needs direction. 3 meters per second. And also the time taken is 5.9 seconds. This just keep random. These are all random numbers. So let's find a speed equation. Speed is equal to distance by time. If you rearrange this and make the distance as a subject, I'll get as, if you do a little bit of algebra, is distance is equal to speed multiplied by time. So I need to know the length of the distance of this train, right? So what I'll do, I have to multiply the speed by the time. If I multiply this, I'll get the answer as 177 meters. If I use my arithmetic skills. Now can you see here? Here is 210 meters in your perspective, but in my perspective, I have 177 meters. See, the length of the train contracts in my perspective. So whoever the observer is, now I'm the observer. So when I watch the train's length is being contracted. This is physical. We can't see it physically in our eyes. But if we go to the speed of light, then we can see that, where scientists still couldn't go at the speed of light. So if you can see, this is only Lorenz's contraction. So this is the main idea of Lorenz's contraction. So now I think that you know what is Lorenz's contraction or length contraction. Please do like and subscribe to my channel. And thanks for watching this video. Bye.